posted because I can't give my boss an excuse to go to a tech meetup during work hours.
All lowercase.
I'm ready when you're ready.
Yeah, care space.
All right.
All
I'm gonna check with the person and then get going.
Cool.
It's care space more, right?
Here's space more, yes.
Yeah, okay. Started second guessing myself.
I'm just gonna close these doors, guys, except the seat.
So I see your aim is to be helpful.
Don't forget the control C at the end of it.
Sorry, I missed the, what was the password?
Oh, sorry.
You gonna say it's care more.
Go ahead, Paul.
Care more, care space more, all lowercase.
Here's more. Get some more today.
All right. Go ahead and get started. Mariah says she's ready. Carson's still watching the door for stragglers in, but that's all right. We can get started. We'll see.
All lowercase.
Sir, hell do I need snacks?
Really quick.
Look at this.
All right. Welcome everybody to the Go user group for May. Looks like we got some new faces, new people in. Welcome. Always excited to have people come and hang out with us, talk about Go. Couple of housekeeping items. The squares above you with the green lights are microphones. They are very sensitive. They're designed to pick up questions that come from the audience. Turns out as a side effect of that, they will pick up whispered conversations that you have amongst your friends. So just be conscious of that. Want to end up famous on YouTube, you can chat in the back, but you probably don't want that. Speakers. We always are looking for speakers for this meetup. Mariah is going to generously offer to speak today, but we really want to help anybody who wants to get into speaking, has some ideas they want to present, to come and be part of the community here. So if you are interested in speaking, think you might want to speak, have a topic you want to speak on, you can go to the paper call link. You can also just hit us up in Forge Slack. That's the best way to kind of stay up to date with what's going on in the community. Carson, myself, Mariah, all of us would be happy to help you get your talk in front of people. If you don't have a full talk, if you just have a lightning talk, that's fine. We basically never say no to anybody. We might have some notes for you, but by and large, we just kind of let people come up and present because this is community driven. Jobs and hiring. Excuse me. Jobs and hiring happen on Forge. I mentioned it earlier with the paper call, but get on the Forge Slack. That's, again, the best way to stay in touch with everybody. Best way to kind of get a pulse on what's going on around the area. If you're looking for a job, if you are looking to network, this is a great place to do it, as well as if you're looking to hire somebody. Go West is happening again this year. Derek Laird, I think, is kind of running it. Mariah is also one of the people putting that together. I think it's happening here on the October 25th. Go West Conf is the website for all the information you might need. I think they're going to put ticket sales up in June, was it? That you said they're going to start selling tickets. And also Call for Papers is up on the Go Conf website, Go West Conf website. So if you want to speak at a bigger conference, how many people showed up last year? A couple hundred. Sorry, what?
70 people.
Okay. So
70 tickets.
yeah. So close to about 100 people. I think it has been bigger in past years. And, you know, a good opportunity for a slightly bigger thing if you don't want to just come and hang out with us. We'll want to present something a little more formal. Good experience if you want to try and build up to present it bigger and bigger stuff. Like this is, it's great. I've presented here before. It's a fun time. Come hang out and enjoy the experience. And with that, I think we'll turn the time over to Mariah to talk about the reader and writer interface.
This title has changed only about 17 times. So.
We got it the word workforce, not the workday.
The word workforce is there. Let me share my screen again.
So I stopped presenting. Yeah. So if you want to present, you should be.
There you go.
Turn off sleep so it doesn't lie on you every 5 minutes.
Pretty sure that I don't even have sleep turned on because I always use it clamshell unless something important happening. Hello, guys. Glad you can make it. I'm sorry you missed my first talk as a Google developer expert in Go. That was at the MLOps meetup. So sorry you don't get to learn about LLMs and LangChain Go this week. We're going to be talking about, oh, that's a Chat GPT generated title. AO Reader and Writer. I don't get my notes because I'm live streaming this on YouTube. That's not the point. Point is, I'm really excited to be here. And I just wanted to start out. Wait, I'm going to introduce myself. Hi, I'm Mariah. If you haven't met me, I used to run this meetup, but then Carson and Brandon generously took it over. So I don't have to run it anymore. I'm here representing Forge. Forge is the parent company of every meetup that's worth attending. Well, there's a couple other meetups that you might want to look at, but every meetup I attend. I have a day job, but I don't do Go there, so nobody cares about it. But I stream Go streams every Friday on Twitch. I make YouTube videos. I've got a Substack, which is the only place you can read my stuff for free anymore because I'm using Medium's paywall. And yeah, that's pretty much all you need to know about me. And I did bring t-shirts. There's t-shirts in the box and they have gophers on them. And they have my Twitch URL because, you know, I put the full one on there in case people didn't know this was the Twitch logo. So I conceived this talk while I was writing, not writing. I was rewriting a Go Web Services course I give with O'Reilly. And I was rewriting it because I was doing work on a Go and data stores course. And I just had this mind-blowing moment that only Mariah would have when I realized that underneath every database connection is the IO Reader and IO Writer interface. And I was like, that blew my mind. Then when I think about it, it's not that, like, it shouldn't be that mind-blowing, but I'm like, what else uses IO Reader and IO Writer? It turns out like everything. So everything uses this. Every web service, I have yet to find something in Go that maybe Matt suggested C stuff. So I didn't look at anything that touches C Go because that's gross. But so far I haven't found anything that runs in Go that doesn't use this interface somewhere. So these interfaces, I talk to them as if it's a singular because they always go in pairs. So how do we change screens? So I want you to raise your hand. We're playing Never Have I Ever. Never have I ever if you've done any of these things. And I'm surprised it's worked. Okay. Never have I ever written a handle func for an HTTP server. Raise your hand if you have written a handle func for an HTTP server. This is how you play Never Have I Ever.
Never have I ever, is that supposed to be if you have not?
No, you do it if you have.
So, because if you have to take a drink.
If you have, you have to take a drink. So we're doing it backwards.
You're the exception.
If you've done it, you raise your hand.
Okay.
There we go. Okay. Has anybody ever created a request that's called by the HTTP client? Good job. Has anybody ever read? Well, that should be SQL, a SQL database, right? Have you ever written to or read from a file? Everybody does all these things. Have you ever read an environment variable? Have you ever accepted a CLI flag or argument? Oh my goodness, you guys, you don't even need to be here at the top because you're all reader writer experts. So every single one of those things uses IO. You're all so smart, so you don't need this Wikipedia definition of what input output operations are. But basically, I had to Google it for completeness of the talk. And if it's a definition, I only accept it from Wikipedia because I don't want to pay college professors books citations, please. So basically, any operation that can basically, if I was just going to see TLDR for our purposes, it's anytime your Go application writes outside of itself or reads from outside of itself. That's going to be our IO in this case. Anytime the Go application reads from outside of itself or writes to outside of itself. Right. So, yep, Go ecosystem, it's anytime it reads into or out. So first, we'll talk about readers. What is a reader? This is the read interface. It's really simple. It only has one function, read. Notice it accepts a slice of bytes, and it returns two things. An int, which is the number of bytes read, and an error when it broke. Pretty simple. Basically, anything that has a read function implements this. Next one. Oh, yes, readers. It's the end of a stream of data. This is interesting. I find where I read this. Every time, but at the level of readers and writers, everything in Go handles data as a stream. Something that that has only a beginning and an end. It doesn't really keep track of anything in the middle. So once the payload is sent, it only cares about going to the end. Treats everything like a stream of data, top to bottom. So it represents the read end of the stream as opposed to the write end of the stream. I thought that was really cool. This is right from Tour of Go. Takes and just I think that's a duplicate. Okay, writers. What is a writer? It's the opposite. Right, it writes that. This one does have two different things because you may want to not start at the very beginning. So you do have an offset, which is an int64. I don't actually know. I assume that that is a byte count, right? So how many bytes are you offset from the beginning? But I didn't actually look because I didn't pull the data, and I am convinced I will never have to implement one of these in my life. If I ever get to the point where I have to implement a reader or a writer, I think I need to reevaluate my career and go into management. So that's just, I don't want to get that low level into the code. So takes it and sends it to Go up. So this is these two things, right? These two are what I'm my thesis for this whole talk is that 90% of the things we do with Go will use one, if not both, of these two interfaces. And so, if that's true, we need to learn how they're used, how to pick the right implementation, and I don't know, maybe a third thing. So, inheriting readers, oh yeah, this is the third thing. Not the third thing, but this is another good thing to know. Readers and writers are inherited everywhere. There are read-writers, which require the read method and the write-at method to be implemented as methods on a type to inherit that interface. There's also read closers, there's write closers, there's read seekers, there's read write seekers, there's probably more, there's more than I can count for these, but this is also kind of, it's good to know that there is so much inheritance of this in the standard library because A, it proves the point I will never have to implement it myself. But B, it shows you that there is a lot of value in having one object that can both read and write, that maintains a single connection to wherever you're going and can do both operations. Closers are also really nice because we all like to be able to close things safely or maybe stop a read somewhere in the middle. So how do you implement read writers? I don't know how to implement them because I refuse to. Like I said, I'll go into management. But what's interesting is that I did a search, and we're going to pull that up. Let's see if this pulls up correctly. See, so this is just the source of Go standard library. we're searching for the read function. So this is the number of times that it's implemented on a struct. The first time I searched, I thought it said 138. That's 238 times that this is implemented as a function on a type in the standard library. That's 238 types that have the read method on it. So I should never, if one of these 238 times does not fulfill my use case, I'll probably write Zig or something else that's not quite as robust. I mean, so that was same thing. And then what about writer? Not as many. Why does this not say, oh, well, that's because Mariah copied the wrong thing. It's right at, right?
Correct.
Right. Not right at.
Right at would be for a writer adder. Writer at? Just writer at.
Writer at?
No, just right.
Right.
Right at.
Not-
is for writer at. Right is for writer. Is there anything that implements right at will implement right?
Okay, you're making me think that my slide, where is my slide? Oh, writer at, okay, I see. I did do the wrong one. Thank you. I copied something.
The writer at interfaces.
Implements writer.
Right at.
Yeah,
They're just.
whatever. I said the wrong thing, but you all know what I meant to say, so
We got you.
this is why we speak at meetups, guys. So, this is just the right function. 304 times. Because it's harder to write than it is to read. But see how we've got write seeker, which would have a writer and a seeker. Truncate writer, buffer. Yeah, so this is just all in the standard. This cannot just be all in the standard library. Is that in the standard? That's something. I've never used that package. So. We know that there's over 300. Every time I search, the number gets bigger. So maybe we'll search again at the end of the talk and see if we go to 350. So how do you implement it? Well, you just add the function, right, to call the interface, but I hope you never have to. So there's that. There's really only a couple patterns I wanted to talk about. Who wrote major type of operations? That should say operations, not operations. It goes pretty simple. They pretty much have two options. It's buffered or non-buffered. Unbuffered, like I said, everything is a single stream. There's only a beginning and an end. Or beginning, end, or error, right? So you either bring everything, or you read everything, or you error, or you write everything, or you error. Buffered operations divide it into chunks. So it reads a whole chunk, then reads the whole chunk, then goes to the next, reads the whole chunk, or does the same thing with write. So it basically just divides the slice of bytes up into smaller slice of bytes into chunks. Did I talk about why you would choose? Oh, dang it. Anybody want to tell me the difference? AJ?
So you buffer for things that might be slow or inconsistent,
That's good.
because if you don't buffer, then you'll get the experience that you would get by default in Rust or at C, where it's really, really slow, even though it's supposed to be really, really fast.
No, Rust could be slow. Oh, is that a hand?
Buffer it is.
Go ahead, Ryan. I'm sure you've got something.
Hello, yeah. Hello. I was gonna say, if you're buffering, you don't want a deadlock. If you don't have a buffer, it's pretty easy to deadlock. So like if someone is wanting to read from one side or write to one side, and there's no buffer in between, then you can have problems where you deadlock, right?
Matt?
Yeah.
You also buffer if you want to seek. Do
Buffer and seek.
stream, otherwise it's.
Also, yeah, I could see that. I've never used seek explicitly. Also, to be fair, I rarely, if not ever, I cannot remember a time where I've ever done a buffered read or a buffered write intentionally.
All of them are, yeah, you do it every time.
Intentionally, I'm not doing it. Let me just say, it's not intentional. Is Mariah ever calling the Buff.io package? No. Is that a bad thing? Maybe, I don't know. So if you just do the IO read all, that just, I'm pretty sure this only implements the reader interface and not the Buff.io reader interface.
This is different. Probably will still, I would imagine it would still buffer, but what you get back is just.
But operationally, you can't do anything on top of, like, it's all handled by the compiler as opposed to intentional buffering, right? So there's this, pretty simple. We're actually gonna run this code later. This is just using the read interface on, and this is how I read every file. I never do anything different, and it's never hurt me. So what does that mean? I probably am writing code that is too simple and
You're actually writing code that's unnecessarily complex.
How do you?
There's io.read file that you can use that will do that in one call.
probably, yeah, but that's not how I think. Thanks, Carson. IO.read file.
With the read file.
How do you handle your?
It would used to be an IOUtil, and then it would.
How do I handle 4 gigabyte models?
OS.read file?
OS.read file, you're right. It used to be an IOUtil read file, then they
I can't read
Deprecated it.
Ryan's chats. Sorry, Ryan. I don't have it up.
I just said that it's os.read file. That's all.
OS.read file.
Yeah,
Thank you.
yeah, anyway. Yeah, it's IOUtil. Yeah, people figured it out.
It was IOUtil.
It was IOUtil, right,
So-
exactly.
Yeah, mess with
Well,
my brain.
Basically, I write my code hard, and this is what I do every time because this is how I remember to do things.
It hurts just.
Do
More
you
complicated.
do large models in Go? Because you're the data group. Right?
Am I doing loading machine learning models into Go programs? No,
Oh, okay.
no. We can talk after about some stuff I have planned, but, no. So when you use classic IO, this is literally, things you need to think about. Does memory matter? Because you're much more buffered reading using the Buff.io package writes more to the system, to the Go apps memory. The garbage collector cleans it up after, but you are doing physical memory writes to keep track of what the chunks instead of just going anyway. We'll show you. It. Highly synchronous. It can also be better for real-time events. Buffered.io uses the Buff.io module. And it stores memory. It basically stores the data in memory before it sends, as opposed to just pushing it out. Same thing with the write. It does a cache before it stores it in its final location. You use it when you're trying to optimize your throughput, when you want better error handling, right? You want error handling if it fails during the write or something like that, instead of just at the end or the beginning, right? People say, if like what I read was that it is easier to write thorough errors because it will fail in the middle of the payload and you can check it then as opposed to at the end of the operation. So I used the same pattern again, Carson. This is why I did it that way.
But this one is the only way you can do that. There's no
But it's
Buff.io
probably
read file.
also overly complex. But it is thorough.
See, we can disagree here. So this is necessarily complex depending on the length and size of your text file, right?
100%. 100%.
was-
I'm not saying I would ship this but this is 100% for comparison purposes.
This gives you the chance to go, the line can be 1 billion lines long and you can process them one at a time without having to load 1 billion lines.
I agree.
memory. So like, there's definitely a place for this.
I'm not saying don't ever use it. I'm saying the way I wrote it might be extra complex. But it was, notice the 2 examples use the same file because that way we can compare on the same data. That was the intention. Also, this was generated by ChatGPT. See, I commented generated example. We'll talk about database implements. Guys, who didn't spell check this? It really wasn't VS Code. So I did some reading. Like I said, my eye-opening thing was with databases. So I dug so deep into the SQL, the standard library, and nowhere in the SQL, the database.sql in the standard library do they call IO except for in a couple of, I don't remember if it was like it was like, anyway, they're not calling IO read or IO write anymore. I think they might have been doing a copy, which is a weird wrapper around the two. No, it wasn't a copy. They're called IO once. But I swear it was like on a logging feature or a timeout feature or a system exit. It was not once in the standard library. It's in the drivers. And I was like, oh, that's why we have drivers. Again, I'm learning basic computer science by comparing this talk, guys. This is what you get when you get physicists writing code, is they don't learn basic computer science. So the database drivers implement IO readers and writers. If you use SQLite, they use Seago. So does DuckDB's Go. They also use Seago to manage this. I don't know why. I just know it caused me a lot of problems with the DuckDB Go driver, because you have to have Seago to build it in Docker, and I can never get that to work. And it streams, that's how it manages between the data store and the app. We all know that when the connection is made, it uses connection pooling to manage that connection and manage your calls across that. And the other thing that I didn't write that I thought about is the other thing you can tell whenever somebody's using the IO package is there's always a close function that you should be writing at some point, a defer close. When you're reading from rows, you've got to close on your rows. When you're receiving, right, when you're doing on your HTTP request, when you read the body, you close the body. When you read from a file, you close the file. So there's your tidbits for coming to the top. Look for if you're doing an IO operation, you should always have a close. If not, figure out why you shouldn't have that close. I want you to know that I took a lot of hard work, and I took the same text that it's Twitch chat, by the way, a Twitch chat log. It's like 10 lines. And I put it in a SQLite database, again, for comparison purposes. And as you can see, we have a DB close. We deferred. I probably should have had a row close somewhere, but whatever. And yeah, inside the driver, we're doing that. We query it and we read it and we scan it. The scan has the IO actually. It's inside scan. Every single one of them. So you can do it over over internet protocol. It uses, it's not the same technically, but it uses the same interface. And also data is sent in a stream, just like data packets. This is essentially how you would do it. You build your handler, and then the response writer and the request take care of all the IO for you. So there's the meat of your talk. Now I get to show you the fun code I wrote. Todd, were you on the stream when I wrote this, or this is the first time anybody's seen this? Guys, I'm so proud of this. I'm proud every time I make benchmark functions. I don't know why. I think they're so hard. So we have, like I said, basically the whole point of these benchmarks, like what's the point of having a demo without the purpose? We're gonna look at different implementations of the IO reader and writer. We're gonna look at how fast they run, and we're gonna look at the number of bytes per operation. Right? So we can say, what are we basically learning how to evaluate? Is this the right use case? And what are my tools for evaluating that? If we're trying to save memory writes, is that the right thing? If we're trying to go fast, is that the right thing? The things. Also, it's an excuse to flex my benchmarking function skills. So this is just 5 lines of chat from my Twitch chat. I copied it off my Discord. Soy LLM bot is a bot I built with a Mistral model. It's running on a Windows machine, and it talks to Twitch. So they are generated by, and then Cowtel's just somebody from my chat. So And yes, the bot does sometimes, probably about 10% of the time, just repeats the last message. Just no context, just straight up repeats it. So this is what we're going to be reading from. I have some benchmark functions. They are literally what I pulled from the code. So this is the read all, and then we have the file buffer read. I have a whole lot more that we can discuss later. Like there's a whole lot of functions down there. But we're just gonna compare for kicks and giggles, the IO read all, the scanner scan, and then the database words. Okay. I have benchmark tests. And they see, I have a lot of, anyway. These are the only ones I'm running right now, and then we can dig into other things in a minute. So we're just gonna compare the three. And I have another hypothesis I'm trying to prove, which is sometimes you should just write to a file and not a database. Not every, just, I love databases, but just occasionally. So we'll do a test, run the benchmarks. If you've never done benchmarking before, that was it. You just write a function and a for loop, and it time boxes it. Right now we're time boxing it 10 seconds. So it runs it either, I think it's like 1 billion times or 100 million times, or until it hits 10 seconds. So whatever happens first. So first time, this was as many times, we only hit 100, no, this is 1 million, right? 1.7 million. So for read-o files, took a couple of nanoseconds per operation. These are so this is the time for each operation, the bytes for each operation, and these Alex is the number of times it had to reallocate new space. So if you don't ever have to write new space, allocate something to the heap, right? So if everything's in the stack, it'll be 0. So if you're trying to, again, optimize for that's how Alex used. I never remember that, but I remember that now. So you see that okay? Do you want me to make it bigger? Now it's not as pretty, but okay. So for the read-o file, right, we see this one ran the most times, which means it was the fastest, right? At 6,000, well, almost 7,000 nanoseconds per operation. This is by far the fastest. With the fewest number of heap allocations and the fewest number of bytes written. Next was this one, again, for speed, there were only 5 bytes, right? So we're not gaining too much, losing too much. But notice how many times it wrote that extra write step, right? When it's caching it, because it saves it before it throws it to its final location. And you end up with double the number of allocations. Obviously, it's doing some rewriting instead of allocating new space to the heap. So that's good. If you have any, and then database, if jump down an order of magnitude, took an order of magnitude longer time, same number of bytes as this one, so we know that it's doing about the same, but it wrote to the heap 2 orders more. So in my head, if you're only writing 5 lines of code, you should just use a file and not a database. If you ever need to, again, if you're doing transactions, if you're searching, I'm not saying don't use a database for what a database is for. If you're just trying to store a state, this is where I'm at when it comes. Files can be so efficient. Anyway, that's the side note. Took us 51 seconds.
Mariah, I had a question on this.
Yeah.
What is counting the Alex per operation? Is that the benchmark?
The benchmark tool is because I have this benchmem true.
Okay.
Like, if I didn't have benchmem true, it wouldn't count the bytes per operation or the Alex per operation. And I almost always, okay, for the number of times I write benchmarks, which is only ever for demonstrative purposes, I always have it on. If you were trying to optimize purely for speed and not for memory, it wouldn't matter. But usually you're trying to balance the two somehow, right? Like it's always that fun game. So cool. Oh god. Now it's really big. I had a couple more we can test. Using just the string.
Ryan has a question.
Ryan had a question?
Yeah, I
You got a
do.
question?
Yeah.
Alright.
So where are you storing this? Like, what database are you? Oh, SQLite.
Oh,
You're
sorry, it's a
storing
SQLite database. So it's a
And then you're
file
just, like-
that's included in the repo.
Right, and then are you just throwing like the text into like a blob or like some big text field?
It's not, so I am literally doing rows.scan to basically, it's taking a username string and a message string in each for loop, and then it's rewriting over that. So I'm not persisting it in memory.
Can you go to the code where you're actually
Yes,
doing?
Yeah, that'd be great.
Right here. See, so I'm not persisting it in memory past the scan. And the same
Right.
thing, do
But
this.
we're reinitializing a database connection for and doing a ping.
Yes, I know I am, because that was the equivalent of what I was doing. I'm also reinitializing the file. This is not,
No, you're not benchmarking how long it takes to write 5 records to an existing database connection. You're benching how long it takes to initialize a new database connection, ping it, and then write 5 records every time.
yes, I am.
And so like it's that initialization is very
But
non-trivial.
I'm also doing the full file initialization as well.
Yeah, but that's
Oh, but it's not the same.
It's
I
not
understand it's not the same.
Yeah.
okay. So like
I'm not trying to-
Just really quickly,
when you have to do 10 times as much work, it's a lot slower.
I'm not,
Yeah,
I'm not
I can-
testing, I am not testing, should we use databases as transactional things? No, I'm saying if you needed to I'm just saying if we were going to do the exact same operation 3 times, which is creating a connection to a file, right? This file just happens to be a SQLite database, right? Reading all of the data from that. That's all I'm testing. That is the purpose of this. Is this good code I would ever ship anywhere? No, this is not the purpose of this.
It's a little apples to oranges, right? Because my answer to that is, do you need a persistent SQLite database? Then you should use that when you're writing your records. Like its performance has almost no bearing on.
Oh, and I would use that. That's not the point I'm trying to make here. The point I'm trying to make here is sometimes, I guess my point is connecting to a database is more expensive than connecting to a file. That was the only point. And right? And we agree on that.
Absolutely.
Okay, that was it.
So will you go back up to where your scan was?
And you're right. If I was trying to do something else, it'd be different. This one,
Yeah, I just wanted to see.
the code that was generated by AI,
Yeah, that's what I wanted to.
it was. Doesn't it look great? I didn't want to think.
Scanner not return the EOF? I guess not.
No, it waits till the end.
Or scan or not scan.
I mean, we could check. It could. I could just be swallowing that. Return the Boolean, as in scanned or not scanned. So since it's in a for loop, if it ever returns a false, I stop. That would be the end of the scan. This returns a string, but since I'm not persisting anything, I just covered it. Are these effective benchmarks? No, but I showed you how to write a benchmark. That was the point. But these ones are more fun. So go past, also, I felt like I needed to include a database one, even though they are a little bit, it is definitely excessive. This was a chat GPT generated one that I didn't like. So here's a fun thing we can do. So this is fun. If you ever, I don't know, if you have anybody of you noticed, I feel like every time I use Copilot, it always suggests to me Byte's new reader with a slice of byte around a string. as opposed to using Strings New Reader. I feel like this is, you might have a different experience because it also is a little bit influenced by the code I write. So I was like, great. If I'm always getting recommended Bytes New Reader with a slice of bytes around a string as opposed to just doing Strings New Reader, let's compare it. Right?
Or compared it with Amazon Q, just trying both of them at the same time.
No, because I have issues with, so Amazon Q, that's a service on AWS, right?
Yeah, it's kind of similar to Copilot. There's some.
Oh, you're saying the suggestion?
Yeah, I've tried Bib. I prefer Copilot, but
I have never tried anything besides Copilot because Copilot works in my Vim setup and I haven't reset anything. I could get Gemini for free in VS Code, but I don't like VS Code except for when I'm making talks. So
The reason I suspect you're getting that is because when you look at Go by Example and other sites, in order to show you what the bytes are, it's easier to cast a string bytes than it is to
oh, I'm sure.
bytes in an example. So the example code that's going to be on Stack Overflow, that's on the demo sites, that's in the lesson material, is going to be wrapping a hello world as a byte.
Oh, let me go comment out the other benchmarks we already ran so we don't run them again. Anyway,
I am actually curious about which one wins this.
this one's a really, this one's, anyway, I don't know why I get that recommendation all the time, but like that is 100% the recommendation I get all the time. And yeah,
Once they start building up off of people's private code bases where they have real code rather than demo code, I'm sure it'll be better.
I think strings readers newer, so there's less.
it might be a newness thing. I just want you to notice this part. All in the stack. That's not what happens in the next one. So that's why it's so much faster. It never has to write to the heap.
I remember about this.
So which one's faster? I mean, are you ever going to notice this in your code? No, I'm not going to notice the difference between 4 nanoseconds and 31 nanoseconds when I'm executing my code. That's not saving me Amazon AWS level money. But one is technically more efficient.
This comes up, I can't remember what it was, but there's a practical reason that this comes up as the way that when you cast between string and bytes.
It's 100%, but it's not a cast. They do a full conversion and they rewrite it. They rewrite the string as a slice of bytes before they read it.
Yeah.
So it doesn't do casting, it always does conversion. So that's why.
Yeah, so there's
The practical
like-
reason is escape analysis is what you're thinking of. Is it will get allocated out to the heap if you aren't careful about it.
Yeah, I hope I never have to worry about that in my life.
I was gonna say I don't think. Well, you it looks like you aren't allocating out to the heap because you got 0 Alex and op, which is good news.
Yeah. I have a couple more benchmarks which are kind of fun. Sorry. This does not help sometimes. Look, I said compare instead of compare. That's for you, Derek. Just so you know, I still can't spell.
Do you know about Vim spell?
Yes, I just don't like it because everything is red.
Oh.
It's like a noise. It feels like too much noise.
How's that problem?
Well, maybe you're a better than me. So I just picked a couple of
stay super tall.
a fun little thing here. I don't know what this does. This doesn't do anything. This was just using b.write instead of bytes new reader. Oh, these are write functions. I did some write testing just for, again, kicks and giggles. It's not as fun as the retesting. IO copy is interesting. Go docs. You can go docs. So the reason that this is interesting, sorry, let's go big here, is because it uses both the reader and the writer. And I'm also pretty sure you can have this be internal facing. So like, I think you can use copy to write directly to your heap and read to your heap if you're kind of clever about it. So it's trippy. It trips me up a little bit. Uses write to or read from. I didn't do copy buffer. Anyway, the SQLite library uses copy. The driver does when it's doing its reads. So
Most languages it's called pipe, but Go pipe is the opposite, which is a little strange. Because it's creating a pipe, it's.
this is literally
Right.
the most I've paid attention to computer science in my entire development career. So that tells you how much computer science you need for people to think you're smart. Yeah, there is. He's just saying it's different than a lot of traditional implementations of pipe. So anyway, back here, and then I just picked b.write because like why not write to? I just picked random ones. I think these are all also all generated because I was just like I was done thinking and I just wanted because nobody in Twitch chat was telling me what to do, so I just trusted ChatGPT. That's what happened. So if you want me to write cool functions, you have to go tell me what to do on Twitch chat. Or you're AJ and you're just streaming at the same time. So that's what you did on Friday.
And I didn't see your comment, I apologize. You like came and left, and I even was looking on the other screen.
Because I was writing the talk on stream. And nobody told me about my spelling errors, so sorry, I'm redoing the reader writer because I just felt like it was more work to uncomment them than it would do the next one.
Which channel, is that on your LinkedIn or where do you?
I post it on LinkedIn and
Okay.
Twitter. It's also literally on my shirt. So look at that. Soy Peak Tech. It's also on Forge Slack. If you're not, I post every time in the random channel. So if you haven't joined Forge Slack, go to forgeutah.tech and it's right on the front. It says join Slack. Clint built that whole website just so I can tell people to join Slack.
More important, it's on the Forge Discord, which is where it's really happening.
Oh yeah, I do have StreamCord incorporated to Forge Discord. I just don't know how to join that. Did I only have Bytes Reader and Stream Builder in here? So they're pretty identical. It's just one's faster than the other. So that was, I could not figure out a good way to benchmark HTTP calls because it requires like a real, I mean, to Carson's point, should you ever benchmark something with an external connection? Probably like an explicit set up a file, probably not. Like it should be some kind of logic for manipulating the data as opposed to, because you're always going to lose time on that API call outside. Todd has a comment. I'm going back to defend my database choice. Yes, Todd?
Ryan has his hand raised.
Sorry, Ryan did have his hand. Anyway, the point is, I'm finishing my thought, then I'll let you speak, Ryan. I couldn't conceptualize a way to benchmark an HTTP call. So go ahead, Ryan.
Yeah, I was just going to say the way that you would want to do that, and I mean, there's two ways, but I guess it depends on your goals. But there is the HTTP test utility, like the library that comes with the standard library, and that will create mock readers and writers and stuff, so that you can actually carry out a full HTTP request. Like that's used a lot of the times when like
I use that whenever I write unit
API
tests.
Huh?
I use it whenever I write the unit tests. It just,
Right.
It was just my mental, which clearly I didn't have any red flags with the SQLite database because it was SQLite making it a file. I just couldn't, anyway, it felt superfluous
Sure.
to like.
Yeah.
Be
Yeah, I was just
creative.
saying, it's I don't really know what you're getting at that point, other than benching the HTTP test library. The other way is opening a local socket.
Yeah, but I guess you would
which-
only be calling the handle func at that point.
There's very little
Efficient.
value to,
Yeah,
I think.
correct. Yeah, I'm just saying that if you wanted to, that's probably how you'd want to. I don't know if you'd want to. So
I don't think there's like Carson. Yeah, I agree with Carson. There's
Benchmarking a handler function,
yes, no, I
100% on
might be
board.
value in that.
but
well, I was gonna say too, you might get some like the handler function that actually gets called if you're benchmarking, like if you have some massive amount of JSON that you're pushing through that connection, you probably want to benchmark that. Like if there's a lot of JSON that has to get pushed over that connection, you could probably figure out like if you're doing a good job of that, and you could like rewrite, whatever and see how it performs.
Yeah, I'm almost wondering if a little bit of abstraction and optimizing additional function calls would be more effective. Anyway.
Yeah, it would be. It would be. Yeah.
Well, that was where I was at. Sorry, I didn't do that, but I did I did database and file. And then the other example was HTTP, which I didn't do, and I apologize. So
Now you gotta benchmark it with TinyGo. See what the performance would be like on a Game Boy.
Brandon, that's your job. So in summary, every Go app leverages IO operations. There's lots of implementations. We should check that again. I'm not kidding. Every time I search that code, it's a different number. And it's always been on this computer, and it's just different Wi-Fi connections. Okay, we're still 238. Should we try the right again? Yes, okay, it didn't change.
It was 304 before.
It was 304.
Down.
Okay.
In front of our eyes, writers are disappearing.
It goes fast, guys. Anyway. We talked about different operations and what they do. Talked about benchmarking and how to tell the difference between them. You can find me anywhere. And if you have any questions, now's the time. Because I did dive deeper. I just didn't want the talk to be too boring. Because benchmarking is for the most exciting part. Any questions? Are we good? Yes, Jason?
You have 2 dogs or just 1 dog?
I do have 2 dogs, Max and Lulu. Lulu's the big one. Yeah, Lulu comes and visits me on Twitch, and Max does not.
Is the one that visits you the bigger one?
She jumps on my lap, and then you can see her on the stream. So, and it usually means she needs to go to the bathroom. Yes, Matt.
Can I just share something I learned recently about readers and writers? I
Please
thought
do.
Interesting is we improved our performance of our program pretty significantly by implementing. So we had a type that has read and write. Maybe it's just read, or anyways, we implemented the at variant, so the read at or writer at. I don't remember which one or both, but
Or you could set the offset.
yeah. No, actually, sorry, it's not at. It was the 2.
Okay.
Read from, write to.
Okay.
Those. It was that pair. Sorry. Read from, write to. And we implemented those, and we instantly got a speed up because it avoids a buffering
Sure.
in between there. But I just thought that was interesting because I had never even thought of it that some guy comes in with the pull requests and speeds up our program by like 50%.
Well, I think that kind of stuff can be a little hard to discover because Go's type system, the function's going to say, hey, I accept an IO reader. And you have to dig into the code to find the interface assertions to see where it's checking. Hey, is the thing actually an IO read to her? And when it sees that, then it can actually use a special. So I kind of wish there was some. You rely on like comments if they're good, or
Yeah,
do
Go
they
comments.
know?
Someone pointed out in the Go Standard Library that IO.copy uses, like Go.doc says it will use read from, write to if they exist.
Yeah.
But for lazy reasons, it's all just copy minimum.
Copy's trippy. I that function I didn't fit in my brain yet. I'll figure it out eventually.
So my guess for why that is that the read does a file system read that is conservatively buffered. But if you have read to, you can be aggressive. That's
In our case, it was just in memory. So there's an intermediate buffer. When you do a read or a write, there's always usually a pretty small, relatively small buffer, a few hundred bytes or maybe a kilobyte or a few kilobytes. But it's when you read from something, you have to put it somewhere
Right,
before you
okay.
can give it back or put it somewhere.
Is it when you're saying 2, you're providing it was an int? Is that no? I'm sorry. Are you providing like a pointer, like a physical address location, or was it just like something else? Do you know, or are you just like, wow, it was faster?
Like in our code specifically?
Just no, like with the interface in general. You could say, Mariah, that question is ridiculous.
It's not ridiculous. I'm trying to make sure I understand the right question. So, because
I'm just saying, when it's read to, right, you're giving it this, right, read, it's read from or write to. Sorry, my goodness. So you're giving it, so currently with read, right, you give it a slice of bytes. So for read from, you would give it a slice of bytes and something else, correct? Or would you just give it the the other thing? 'Cause
You
I
think-
feel like,
Give it a reader. Read from.
you might give it a reader.
You're thinking about it the other way. So
I
all
was
of your
thinking
code
of
so
it
far is.
yes, it's
Well,
not
you're
written down,
approaching
so
the
I'm.
code so far from the idea of passing to things. What
Yes,
we're talking
I'm
about
probably
here is
doing
when
that.
you start to receive these interfaces in your functions, the ways that you
Okay.
can receive an IO reader, but also say, hey, if you're an IO reader, you have to be an IO reader for the compiler to allow you to be passed. But I could also say, and this happens a lot in the standard lib, once I've got that thing, I can do an interface type search and say, I know you're an IO reader because the compile checked, but at runtime, right now, not a compiler check, but like, do you also implement this other interface? And if you do, then I can be more efficient. So that's what we're talking about, and it's sort of the reverse of the way you've been testing.
this was new to me then when I learned.
Weird.
So it's reader from accepts a reader instead of a slice of bytes.
So you're,
If it already has, if the reader already has
Oh, I see.
a buffer there, you don't need to make another buffer. You just read from the buffer.
I see. That makes sense now.
So anyway, if you can implement read from, so it's reader from or writer to, if you can implement those, your program will get faster.
Well, I guess each of those, like a write to, would be able to be implemented with its own internal buffer, fill up as much of the buffer at a time as it likes, and then keep using that slice.
That's exactly what buffers are intended to do, yes.
Where then it would be able to do it with an internal buffer and never have to allocate.
Add the additional one, yeah. Right? Oh, that makes sense. That was the thing I looked for and never found while I was writing this talk, so I'll have to add it before I give it again in June. Anybody have any other, besides fixing all the spelling mistakes, any other things they want to add?
I actually had, I've been working on a personal project, trying to use, Bubble Tea to write a terminal UI application. And the interesting things that I found is that internally, it uses this framework called Reflow, which is an ASCII, like escape codes to change your colors and fonts and stuff in the terminal. It will use writers, and then it will monitor the bytes that come across and look for fancy escape codes that change the styling. And it will capture that, but also pass it on to the delegate writer. And then when you slice and dice content, it will be able to remember, like when you have a line break, it will remember, okay, what is the latest ASCII style that we have? It will do a reset at the end of the line, and then it will reinstate it at the beginning of the next line. So that when you want to join two bits of content side by side, it can preserve the styling on all of those. I thought that was a really interesting use of a writer where it was basically just interpreting those ANSI escape codes as the bytes were going through.
Is it making almost like a shadow DOM?
Not
It sounds like it's keeping track internally of.
really, it's actually a complete redraw on every frame, but it's fast enough. The only thing that it does is it will measure how wide space.
Cool. Awesome. That's all I got.